Oh, testing, testing, testing. No, testing, testing. Cool. Hi, welcome back to our channel at Kangaroo Study. I'm teacher Cedric, and just as just for testing, could you type a 1 in the chat if you can hear my voice? Because I see we have some participants in the chat room. If you can hear me loud and clear, could you type a 1 in the chat? And then after that, we will begin. Reading your live chats because there's a slight latency between the chat room and my screen. So still waiting for responses in the chat room. So if you can hear me, if you can hear my voice, would you type it 1 in the chat or type anything in the chat just to let me know that you can hear me and if the volume is okay. Okay, cool. Yes, now I can see some responses in the chat room. Thank you. Cool. Now let me bring up my laser pointer first before we're going to start. So, welcome back to our channel. I'm teacher Cedric, and today we're going to go through some area problems in paper 2. Now we know geometry problems in paper 2 are quite difficult in general, and geometry problems can be put into 3 groups. Well, first, the angle problems, which is what we went through 1 week ago physically. And the second type of geometry problem in math PSLE paper 2 is perimeter problem, where you have to figure out the perimeter of some shape. And third of all is area problems, which I would say one of the most difficult type of problem in PSLE paper 2. But today we're going to go through some ideas and some techniques behind solving this kind of area problems in paper 2 so that you'll be able to ace any geometry problems if you see one in the PSLE math this year. Let me check the chat room. Cool. Now, let us have a look at the first question. So we have these questions from PSLE 2022, paper 2, question 8. So Join is designing a logo as shown below. The logo is made up of 3 small identical quarter circles. So here are the 3 quarter circles and a large quarter circle, which is this one over here, with 2 straight lines joined inside a square of side 42 centimeters. Well, that's good news. We always like to solve squares because we know all 4 sides are the same. Now, given that the radius of each small quarter circle is 14 centimeters, so that means this part over here, this length over here is 14 centimeters. What is the perimeter of the shaded part? Also, these 4 shaded parts add together, this perimeter, and second of all, what is the area of this shaded part? Now, let us do this step by step, focusing on the first part of this problem. What is the perimeter of this shaded part? Well, let's see. If we take this part example, I will see that this, as stated in the question, is a quarter circle. Now, do you remember how to find the perimeter of a quarter circle? Well, we know that the formula to get the perimeter of the circumference of a circle is 2 times pi, which we take 22 over 7 over here, times the radius, which is also given by the question. Now, this part over here is the circumference or the perimeter of a circle. But since we only have a quarter circle over here, then we have to divide this or multiply with 1 over 4 to get 22 centimeters. So this 22 centimeters correspond to this length over here. Now, this length and this length would all be identical to this one because, as you can see, they made up a big circle. But now, this is only the perimeter of this circle over here. What about these two lengths? Let's see. Well, first of all, we know that the side of this square is 42 centimeters. And we know that the radius of each of these three quarter circles is 14 centimeters. So this length is 14. This length is also 14. So this length would be very good. We can take 42 minus 14 to get also 14 centimeters. So that these three lengths over here add up together to get 42, which is the side of this square. Now with that, how am I going to find this length over here? Well, we see that this is also a quarter circle, but a bigger one. Now, can someone tell me what is the radius of this big quarter circle over here? Well, I can see the answer in the chat. This one would be 24 centimeters because we take 14 plus 14. That's the radius of this big quarter circle. So again, we take 2 times pi times the radius to get the perimeter times 1 over 4 because we only have a quarter circle over here to get 44 centimeters. So that means this arc over here is 44 centimeters. So in total, the perimeter of this shaded part is 22 times 3 because we have 3 quarter circle plus 44, which is this arc over here, plus, don't forget, this straight line over here, 14, and this straight line over here, 14, to get 138 centimeters. So that solved the first problem. Now, moving on, how are we going to find area of the shaded part? Well, let's see if there are any area that we can find in a straightforward manner. Well, we see that again we have 3 quarter circles over here. Now, in order to find the area of a quarter circle, what do we have to do? Very good. We can first find out the area of a circle and then divide it by 4. So we take pi times r squared, which is 14 times 14 divided by 4 to get 154. So that gives us the area of one of these quarter circle. Now, what about this part? This weird looking shape that doesn't look like a triangle, but how am I going to find the area of this part? Well, the trick is, whenever you see a shape that you're not familiar with, where you don't know about its area formula, you always try to see if you can do some cutting and pasting or subtracting to get from a familiar shapes and then turn it into to turn an unfamiliar shape into something that you're familiar with. So over here, we see that this is actually a square with side length of 28. And we see that this blank area over here is actually a quarter circle. So in order to get this shaded part over here, we can take this square, the area of this square, take away the area of this quarter circle, this big quarter circle. Then we'll be able to get the remaining, which is this weird looking shape that we're trying to find over here. So to do that, we first find the area of this square, which is 28 times 28, minus the area of this quarter circle, which is pi times r squared divided by 4, because quarter circle. To get the area of this shaded part is actually 168. Now that helps us find the area of this weird looking shape that kind of looks like a slope. So in order to find the total area of the shaded part, then we simply have to combine these 4 areas. So we have 3 times 154 because we have 3 quarter circles over here, plus the area of this slope over here, which we found that it's 168, to get the final answer 630 centimeters squared. So that's how you find areas of some weird looking or irregular shape. We always try to subtract the area of the unshaded region in order to turn an unfamiliar shape into a shape that we are very familiar with. So that's the technique that I would like to introduce to you guys in order to help you solve a lot of irregular shapes that you're going to see in PSLE paper 2. Now moving on, let us have a look at the next problem. So for this one, we have a PSLE problem from 2020, paper 2, question 5. Now, a square is first divided into two equal halves. So the top half and the bottom half, they are equal. And given that the top half is divided into 5 equal parts, while the bottom half is further divided into 4 equal parts, the total area of the shaded parts of these 5 shaded parts combined together is 165 centimeters. So what is the area of this square? Now, let's see. We know that the total area of the shaded part is 165, and we know that this square has been split into two equal halves, top and bottom. Now, we see that this shaded part in the top half consists of 3 units. There are a total of 5 units in this top half, while 3 units are shaded. But for this bottom part, it consists of 4 units, and these 4 units are completely different from the 5 units at the top. And on top of that, 2 units out of these 4 units over here are shaded. So we see that the units of the top half and the bottom half, at least for now, do not match each other. Now, in order to unify these 2 units, in order to have them match together, what thing do we need to find in order to unify the 2 units? Let me have a look at the chat. You are going to have to find the LCM, the lowest common multiple. Whenever you try to unify some units, we always try to find the LCM of 2 units. So let's see, on the top we have 5 units and on the bottom we have 4 units. So what is the LCM of 4 and 5? Very good, that will be 20. So let me try to first dissect this square into 20 parts, which I'll draw some lines. So that now if you look at the top half, we have 4 units, 4 units, 4 units, 4 units, 4 units, so a total of 20 units, and at the bottom we also have 20 units. So now let's check what are the fractions, what are the portion of the shaded parts. Now over here we see that we have 5 units shaded, another 4 units, another 4 units, and another 4 units. And at the bottom, we have 5 units over here and 5 units over here. We can count 1, 2, 3, 4, 5. So we see that this shape over here consists of how many units? Consists of 40 units. But then only 22 units over here, these 5 numbers add together, are shaded, which constitutes 165 centimeters squared. So we know 22 units correspond to 165 centimeters. So if we can find that 1 unit is just 7.5 centimeters squared. So what is the area of the square? We see that we have a total of 40 units over here. So we simply take 40 multiplied with 7.5 to get 300 centimeters squared. Now that solves the problem. And again, let me quickly recap what we have done. Now, when we first look at this problem, we see that the top half and the bottom half, the units does not match. And we learned that in order to unify 2 units, you always need to find the LCM first. And with the LCM, you unify the units, and then from there, you can work out the answer fairly simple. So that's the second question of the day. Now moving on, let us have a look at the third question. Now this is a question from PSLE 2018, paper 2, question 7. Now, the pattern on the tile ABCD shows three overlapping squares of different sizes. And we know that AF over here equals FE and AE equals ED. So this is the midpoint of DA and F is the midpoint of E. Sorry, E is the midpoint of DA and F is the midpoint of EA. Now, the first question, what fraction of the tile ABCD is shaded? How can we find what fraction of the tile ABCD is shaded? Well, we see that we do have some shaded area over here and some shaded area over here, but we have this blank area over here. So how can we figure out what are the fraction of the tile ABCD that are shaded? Let me have a look at the chat room to see if someone have any idea or suggestion. There's a slight delay between the chat room and my screen, so I'll try to wait for a moment. Any idea? How to figure out the fraction of the tile ABCD that is shaded? Well, very good. I can see in the chat this. Hang on. Someone is typing. Well, we still have some new response. Divide square. Okay, very good. I can see that we do have some area. Sorry, we do have some idea about finding the areas of the shaded parts in this tile ABCD. And I can see that we can all agree that when we are talking about fraction, we need to figure out what are the portion of these two different shaded areas. Now let's see. We can treat this big square over here, ABCD, as one unit, and then we can investigate what portion of this one unit constitute in this big square. Or we can do this another way, where we start from the small square. For example, the small square on the right, we treat this one as one unit, and then we investigate what are the total units. Now, which of these two approaches would you think would be easier for us to work with? Should we start from the big square or should we start with the small square? I'm looking at the chat. So my question was, should we start with the big square or should we start with the small square? Which one do we treat as having one unit would be easier for us to figure out the portion or the fraction? Well, in this case, if you treat the big square ABCD as having one unit, then you have to deal with fraction. For example, what is the fraction of this middle square over here in terms of this big square over here, ABCD? Well, we see that this is actually a quarter of it. And on top of that, we see that this small black square over here is 1/4 of this middle square. So again, that's 1/4 of 1/4. Now, you can solve this problem this way, but if you're not so confident with dealing with fractions, which I will try to avoid, then maybe starting with the small square can help us avoid dealing with fractions. So, in this case, I would treat this small square over here as 1u. Very good, I can see in the chat that we can all agree that we should start small. So I can treat this small square over here as 1u. So given that this small square is 1u, what is the area of this blank space over here? Just this white area over here. What is the area of this blank space? Could you type your answer in the chat? I'll wait for your answer. And again, if you are watching the replay of this, we do have some latency between the chat room and my screen, so you might have to wait, you might have to fast forward a bit. I can see that we can all agree that we should start with a small square, but now, if I assume that this small square is 1u, then what is the area of this blank space over here? Or what about this big shaded region over here? What is the area? Still looking at the chat? Very good. I can see that some students say that if this one over here is 1u, then this blank space over here should be 3u. Very good, because we see that this f is the midpoint of this middle square over here, and on top of that, this is a square, this is also a square, so that we know this point over here is also the midpoint. So if this part over here is 1u, then here is also 1u, here is also 1u, and here is also 1u, so that the area of this blank space is 3u. And very good, I can see that in the chat, someone said that this big shadow region should be 12u's. Now how can we figure out these 12u's? Again, we say that the total area of this middle square is 4u's. And how many this middle square consists can be found within this big square ABCD. Well, here's one, here's another one because E is the midpoint, and here's the third one, and here's the fourth one. So we see that over here, we actually have 3 of this middle square, which has the area of 4 units. So the area of this part, this big shaded region, should be 12 units. Now, what fraction of the tau ABCD is shaded? Now this is fairly simple. We see that the shaded part is 1u plus 12u, and the total area of this tau ABCD is 12 plus 3 plus 1, which is 16u's. And the u's on the top and the bottom cancel each other to see that, oh, actually 13 over 16 of tau ABCD is shaded. So the answer to the first part is 13 over 16. Very good. I can see that in the chat, a lot of you did found the correct answer. Now moving on. For the next part, figure Y. Figure Y is made up of 4 such tiles. So if we use 4 of these tiles, we can put them together to form this figure Y on the right. Now, given that the area of the unshaded part of figure Y is 81 centimeters squared, what is the total area of the shaded part? These squares and then this ring-like shape combined. What is the area of the shaded part? Well, again, let's see. Now, we know that this figure Y consists of 4 of this tau on the left. So first of all, let me draw them out. So this is one of the tau, this is another one, the third one, and the fourth one. And these 4 tiles are all identical. Now, we know that this shaded part is 81 centimeters squared. So how can we figure out the total area of the shaded parts? Let's see. Well, before this, when we're solving for the first part of this question, we have concluded that this small square to the right of a tile is 1 unit, and this blank space is 3 units out of the total 16 units. So if you're just focusing on one of these 4 tiles over here, this blank space actually consists of 3 units of the total 16 units. Now, the same apply to this tile to the left, because like the question stated, they are equal. So this is also 16 U's, this one is also 16 U's, this one is also 16 U's, and then on top of that, we see that this blank space actually consists of 3 units of each tiles on the right in this figure Y. So what is the fraction of the unshaded parts in this figure Y? Let's see if you can get this question correct in the chat. What is the fraction of this unshaded parts of this figure Y? I'm reading at the chat to see if some of you could give me the correct answer. What is the fraction of this blank area of this figure Y? Yep, very good. I can see some answer in the chat. So this is 3 units out of the 16 units. This is also 3 units out of the 16 units. 3 units out of the 16 units, 3 units out of the 16 units. So we see that since these all 4 tiles are identical, this blank space actually constitutes 3 units of this entire figure Y, and then the total area of the figure Y can be treated as having 16 units. So we see that this 81 centimeter squared corresponds to 3 units. And in order to find the total area, which has 16 units, we can simply take 81 divided by 3 multiply with 16 to get the total area of this figure Y for 2 centimeters squared. Now, that solves the second part of this problem. Moving on, let us have a look at this problem where we have a circle, four small circles lying in a big circle. In the figure below, the radius of the largest circle, which is this large circle over here, is 7 centimeters. Now, can you find the area of the shadow region? So these are all the shadow regions in centimeters squared. And you can take pi as 22/7. So how are we going to find the area of the shadow region in this case? Well, first of all, maybe we can try to find if there are any area that we're familiar with and we do know about the area formula. Now, can you find any of such area in this shape? Well, the answer is no, because we see that, this is I will call this a leaf shape. Now, we do not know any area formula of a leaf shape, so I'll keep it aside for now. What about this shadow region over here? Well, that looks kind of like a slope, a circular slope shape with 2 arcs. And again, I do not know the area formula of this shape. So we have a lot of very irregular shapes in this circle. How are we going to find the shaded region? Well, the trick is, let's see. I'm not going to tell you the trick for now. Let us try to investigate this shape further. Now, there's something special about this shape. Is that we see that we have this 4 leaf shape over here, which I will call them a convex shapes because they have this convex arc to the left and to the right. So we have these 4 convex shapes, and then around this circle we have these 4 parts over here, which I will call them as a concave shape. As you can see that they concave into the perimeter of this circle. We have this concave area, we have this concave area, and then over here we have this convex shape as, a leaf shape. So whenever you see some concave area, some concave parts, and some convex parts, well, you can always try to see if you can fill in those convex part with those concave part with this convex part to see if you can fill them up so that you can get a straight line. And in this case, we can see that we can actually do this. Then the trick is that we can split these 4 leaves over here as a cross. So now I can cut these 4 leaf shapes into this convex part on the top and another convex part at the bottom. And from there we see that I can bring this part to the top, this to the top, and this two to the left, this two to the bottom, and this to the right to get this shape over here around the circle. And since we have already bring this over here to the surrounding, let me remove it. So now we see that the area of this shaded region is actually the remaining parts of a circle subtracting a square. Now, how am I going to find this shaded part? Again, we can use the technique from the first question, where we subtract the unshaded part from the total area to get the shaded part. Now, the total area is this square. It is circle, so you can take pi times r, the radius of the circle 7 times 7, so 7 squared, and then minus the area of this square. Now, how am I going to find the area of this square? Well, we see that this is the diameter of this circle, which is 14. And then this is the radius of this circle, which is 7. So we can take base times height divided by 2 so that we find the area of this triangle. And since this is a square, we can multiply this by 2 to get 56 centimeters squared. So taking the total area, subtracting the unshaded part, will get 56 centimeters squared, which is the answer to this problem. So the area of the shaded region is actually 56. And again, let me summarize this method, this technique that we just used. If you find some irregular shapes, especially if they are circular, you will find some concave parts and some convex parts. And then the next thing you need to do is that you try to fill in those concave parts with the convex parts by using what I would call as a cut and paste method. That way, you can transform an unfamiliar or irregular shape into something that you are more familiar with, and then you'll be able to find the area. Now, that's the last question of today. So let us quickly do a review, a quick revision on what we have just learned. Now, starting with the first question, we see that in order to find the perimeter of this shape over here, we first put them into different first put them into different sections. For example, this one over here, this one over here, and this one over here. And then we try to see if we can find the perimeter of each of these segments. And especially this thing over here is a big arc of a quarter circle. And then don't forget, now many of you made this mistake during the exam. Don't forget about this length over here and this length over here, because in order to get the perimeter, you need to walk along this shape exactly once. During the exam, you can try to do this. You take your pen and then you follow this perimeter to draw them out to check if you have missed any segments, any line segments. And once we have found the perimeter, in order to find the area of the shattered part, we see that these three quarter circles are relatively easy to find, but then for this weird looking slope shape, what we did was we first find the area of this square and then subtract with this big quarter circle, so that the remaining area would be this shattered area that we are looking for. So let me put this as subtracting the area of the unshattered region. This is a very useful technique that you're going to apply in a lot of geometry problems, especially in finding areas. Now moving on, we have this problem where the square are not divided equally in the top half and the bottom half. We have 5 units in the top and then 4 units at the bottom. So in order to figure out in order to unify the units at the top and at the bottom, just like all the word problems that we did, you always need to find the LCM first, the least common multiple. And by that, we find that the LCM of 4 and 5 is actually 20. So we can first dissect this square into 20 units at the top and 20 units at the bottom to see that actually these 5 areas over here add together to 165 areas. 165 centimeters squared. That's the area of these 22 units. And we can easily find 1 U and then 40 U's correspond to 300 centimeters squared. So that is the area. So that is how we solve this problem, by unifying the units with LCM. And moving on, for this one, we see that if this small black square over here is 1 U, and then this blank space over here is 3 U of this tile, then if I put 4 identical tiles all together, combine them, then this blank space is still going to constitute 3 units of the total 16 units. So you don't have to treat this as 3, 3, 3, 3, and then 16, 16, 16, 16, which will give you a very big number that are a bit more complicated to deal with. If it constitutes 3 units of a tile, and if you put them together, it will still constitute 3 units of the total area. And from there, we can work out what is 1 unit multiplied with 16, the total units of this square figure y, to get 432. And finally, we have learned that if you have especially a circular shape, the thing you would like to do, and if there are some irregular shapes like the leaf shape or this slope-like arc shape, the thing you can do is that you can first try to fill in this concave area with this convex area. Now, don't confuse yourself with these two words. You can always try to fill in these concave areas with the convex area to get this shape over here. And then you get to know that this shadow region is actually the remaining part once you subtract this square from this big circle. And by that, we find that the answer to this problem is 56 centimeters squared. So you can write down on your note that this cut and paste method especially works when you try to fill in the concave part with the convex part. Now this is going to help you solve a lot of geometry problems, especially when it involves circular, arc, or any kind of irregular shape. So that's it for today's PSLE webinar on area problems. And in order to, if you want to learn more about PSLE Paper 2 and get notification on our next PSLE webinar or the next PSLE workshop, make sure you join our study groups on WhatsApp for P1 and P3, P4 and P6, and of course, if you want to join our secondary school to learn more about the syllabus for secondary school, you can also join our secondary school study group on WhatsApp. That's it for today. I'm Teacher Cedric, and I'll see you soon. Bye bye.